Welcome learners to a natural science lesson for today. So today we're going to be doing some practice questions and then some application questions based on the particle model of matter. So let's begin. So we're going to start off with an easy question whereby now we're going to draw the particles of a liquid and a gas when we are given those of a solid. So we know that the particles of a liquid, they take up the shape of the container and the spaces between them is slightly bigger than the spaces of the solid. So you're going to draw the particles that are making up a liquid and the particles that are making up a gas. You must always remember that the spaces between our water molecules, not our water molecules, our liquid particles is slightly bigger than the spaces of a solid. And you must always remember that those particles will always take up the shape of the container. So because our container is a circle, the particles that are within that container, they are going to be also arranged in a circular pattern. Now, with regards to the gases, remember the gas particles, they have spaces that are much larger than the ones of a liquid and those of a solid. And they are arranged in a random fashion. They do not have any specific shape. They are just arranged in a random manner. They don't have any specific shape. And if we were to label our diagram, this is going to be a solid, this is going to be a liquid, and this is going to be a gas. So as we can see, the spaces as you're moving from the left-hand side to the right-hand side, the spaces between the particles gets bigger and bigger, and the shape is different. From a solid, it's a rigid shape, whereas in a liquid, it takes the shape of the container. However, in a gas, it's just random, there's no definite shape. Moving right along, why are we able to pour liquids from one container to the other? Why are we able to pour a glass of water from one container to a different container? Is it because they do not have a definite mass? Or is it because their particles are not as strongly packed as in a solid? Or maybe is it because they tend to take up all the volume? Or is it because their particles are tightly packed as in a solid? Why are we able to pour liquid from one container to the other? I know it's not because they have a definite mass, so it can be A. Because their particles are not as strongly packed as in a solid. That's a possibility. Because they tend to take all the volume. No, they do not tend to take all the volume. Is it because their particles are tightly packed as in a solid? Remember, the particles in a liquid are not as tightly packed as in a solid, so therefore it also can't be D. So therefore our answer is B. Next question. We need to fill in the blanks now. We are given that something and something are particles of matter. What makes up matter? We said that atoms and molecules are particles of matter. And the second question is, the particles of matter are in a state of continuous what? So we know that the particle model of matter theory tells us that the particles are always in a constant motion. So therefore, this is going to be motion. The particles of matter are in a state of continuous motion. They are always moving, vibrating, sliding across each other, and also moving in a random direction as they do in gases. Third question, particles of matter have something between them. They have two things between them. They have, you can either say spaces, or you can also say attractive forces. So particles of matter have spaces between them. And then also the particles of matter, they have attractive forces between them. That's what holds the particles together, right? So as we move right along to the next question, the question says, Something is a process in which particles move from a highly concentrated area to a low concentrated area. That's now the movement of particles from one concentrated area to a low concentrated area until equilibrium is reached. That makes me think of something. It is diffusion. Diffusion is a process in which particles move from a highly concentrated area to a low concentrated area until equilibrium is reached, or until the particles are evenly distributed. So my next question is saying, gases have neither a fixed something nor a fixed something. So we need to think of the properties of gases. The properties of gases, they're saying that they do not have a fixed shape or a fixed volume. So therefore, the gases have neither a fixed shape, nor a fixed volume. Right, that was easy enough. Moving on to the next question now. Is it true or false? Are the following phrases true or false? Any substance can exist in 3 states of matter. That means any substance can sometimes be a liquid, and then in other times be a solid, in other times be a gas. Is that possible? Not all the substances can live in or can exist in those 3 states of matter. So therefore, this statement, it is false. We can think of water, which can exist in all 3 states of matter as a block of ice, as a liquid water, and also as gas in the form of water vapor. Then the next question is saying, if 100 grams of a gaseous substance fills all the space in a container, then 50 grams of that same gas fills half of the space of the same container. So now the assumption here is that this gaseous substance has a fixed volume. Remember that gaseous substances, they do not have a fixed volume. They're dependent on the container. If the container is 2 liters of a container, the gas particles are going to fill up that entire space. The same number of gas particles can fill up a space that is maybe a 1 liter container. So it depends on the space that you have. So therefore, this statement is also false. Next question. The particles of matter are in continuous movement. The model teaches us that the matter is made up of particles which can either be atoms or molecules. And those particles are always in a state of continuous motion. So therefore, the particles of matter are in continuous movement. So that means the statement, it is true. Now, next question. When we compress a gas, its particles become smaller in size. So if we take a 2-liter container and you pour gas particles there, and when we decrease the container, does that mean the gas particles within that container, they shrink and become smaller in size? If we, let's take you as an example. You and your classmate are in a class, and there's 30 of you. If we now decrease the shape or decrease the size of the class, does that mean you as a learner, as an individual in that class, you decrease in size? You don't decrease in size. What decreases is the space that you're going to occupy. So therefore, the particles of gases, they do not decrease in size. However, the space that they occupy is going to decrease. So therefore, this statement is also false. And the last one says, when we expand a gas, its particles increases in size. There was 30 of you in a class. When you put in more 30 schoolmates of yours, are you going to increase in size? You do not increase in size. However, the space that you're going to occupy becomes smaller and smaller because now there's more people there. So that means this statement, it is also false. Which brings us to the end of our practice questions. We're going to quickly take an ad break, and I'll see you just after this.